Hello everyone. In this presentation we will explore the polar and rectangular representation of a sine wave. These two methods describe the same waveform but in different coordinate systems. Understanding both representations helps engineers analyze signals more effectively in mathematics, physics, and electrical engineering. A sine wave is a smooth and periodic oscillation defined by several important parameters: amplitude, frequency, period, and phase. The amplitude represents the maximum height of the wave. The period describes how long it takes for one full cycle to repeat. The frequency indicates how many cycles occur per second. The phase determines the horizontal shift of the wave. Sine waves are fundamental in many scientific and engineering applications because they model many natural and electronic signals. The rectangular coordinate system uses a horizontal axis and a vertical axis to represent values. The horizontal axis usually represents the independent variable, such as time or angle. The vertical axis represents the dependent variable, such as the amplitude of the sine wave. When we plot a sine wave in rectangular coordinates, we can clearly observe how the signal oscillates over time. In rectangular representation, a sine wave is plotted as amplitude versus time or angle. The amplitude represents the peak value reached by the wave. The period is the horizontal distance between repeating peaks and corresponds to one full cycle of 2 pi radians. The phase shift represents the horizontal translation of the waveform along the x-axis. This form makes it easy to visualize how the signal changes over time. Polar coordinates describe points using two values, radius and angle. The angle, usually represented by theta, defines the direction around a circle. The radius, represented by r, describes the distance from the origin to a point. Using polar coordinates allows us to represent signals in terms of magnitude and direction rather than horizontal and vertical positions. In polar representation, the sine function is expressed as a radial value that changes with the angle. For example, when the radius is defined as r, opening parenthesis, theta, equals sin, theta, r, theta, equals sin, theta, the distance from the center changes as the angle rotates around the circle. This produces a distinctive curved pattern that visually represents the sine relationship between angle and magnitude. It is possible to convert between polar and rectangular representations using mathematical relationships. For example, when starting from a polar function such as r, opening parenthesis, theta, equals sin, theta, r, theta, equals sin, theta, the rectangular coordinates can be expressed using parametric equations. These equations map the radial distance and angle into x and y coordinates. This transformation allows the same function to be analyzed in both coordinate systems without complex derivations. Both representations describe the same mathematical function but emphasize different perspectives. In the rectangular plot, the sine wave appears as an oscillating curve along a straight horizontal axis. In the polar plot, the same function is represented as varying radial distances around a circular path. Although they look different visually, they describe the same mathematical behavior. Sine wave representations have many practical applications. In oscilloscopes and signal analysis, rectangular representation is used to visualize how signals change over time. In electrical engineering, polar representation simplifies phasor analysis by focusing on magnitude and phase relationships. In communication systems, polar representations help analyze modulation and signal processing techniques. To summarize, sine waves are fundamental signals used across many scientific and engineering fields. Rectangular representation shows how the waveform changes over time, while polar representation describes the signal in terms of magnitude and angle. Both forms represent the same underlying function, but each provides unique advantages depending on the type of analysis being performed. Thank you for your attention. If you have any questions or would like further clarification about polar and rectangular representations of sine waves, I would be happy to discuss them.